Okay. All right, so when you're finding out if shapes are similar, what do they need to have? What do they need to have? Congruent angles. How many of the angles need to be congruent? All of them. Okay. And
the sides have to be able to...
the sides have to be what? Proportional. What does that mean, proportional? When you reduce it, they all equal the same thing. Or the other way of thinking about it is you multiply by the same thing on every side to get to the other side. So to test if something is similar, typically, like down here, we only had to do one proportion because you know since it's a parallelogram that if these two are proportional, then the other two would be proportional since they're congruent. However, with the triangle, you have to test all three. All right? Do you think you really have to figure out if all three angles and all three sides are congruent? No, probably not. Remember when we first started figuring out if triangles were congruent? And we said, to be a congruent... Okay, then I'm just going to put it on my desk because I said put it away. So when we first started figuring out if triangles were congruent, we said you need to know all three sides and all three angles, and all of them have to be congruent. But then once we went through it, we came up with five different like shortcut theorems, like SAS, HL, ASA. What were all of those? Yeah, like what does side angle side mean? Another way to prove a triangle is congruent, instead of proving all three sides and all three angles, you could just prove that all three sides for SSS, or two sides and an angle for SAS, or two angles and a side for ASA. So all of those, why do we have those? What's the point of those? It's a shortcut. What do you mean by a shortcut? Like instead of finding all of them, because that's a lot of work, we can just find a couple of them, right? So the same thing with similar triangles. There are shortcut ways to prove that triangles are similar. There's a smaller amount of information that you can get to prove that triangles are similar to each other. So those are the things we're talking about today. And there are three theorems, and they look very similar to the ones that you did with congruency, so they should be relatively simple. So one of them is AA. So if you know that two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Does anybody know why this is the case? Why is it enough just to have two?
Oh, because the other side would have to...
Yeah, if you know two of the angles, what do you know about the third? It's also congruent. So really, once you know that two of the angles are congruent, you know that three of the angles are congruent, and that's enough to prove that triangles are similar. Okay, so if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it's enough to say if you have two angles, then they must be similar. So we just need A and B and D and E here to prove that those two triangles are similar. Does the order of the letters matter? Yes? Why?
Because you want to match the same one.
What do you mean by the same ones? The ones that are congruent to each other have to go in the same spot, right? So if you start with A, that has to go in the same spot as D and so on. So ABC would be similar to DEF. Okay. Side, side, side similarity, same thing. If you know that three sides of one triangle are proportional to three corresponding sides of another, then the triangles are similar. Again, here, they don't, side, side, side doesn't mean they have to be equal. It means they have to be what? Similar, proportional. And what's proportional again? Bianca said they all reduce to the same thing. Okay? So for example, are these two triangles similar? Yes? Why? So how would I do? You divide them by 2. You multiply them by 0.5, divide by 2. Same thing, right? So divide them each by 2, and that gives you this triangle. Therefore, this triangle would be similar to this one based on SSS similarity. Can you prove that they're congruent? Are those triangles congruent? Are these triangles congruent? No, they're not congruent because they have different sides. So that's the difference between SSS, what we've done before, and SSS with similarity. Similarity does not prove that they're the same. It just proves that the sides are congruent. And if you know that, or I'm sorry, not congruent, proportional. But if you know that, what can you say about the angles then? The angles have to be congruent. So this angle right here would have to be congruent to this angle. This one would be congruent to this one. And this one would be congruent to this one. Okay? So that's the second one. And then the last one is side angle side similarity. So here, just like SAS before, instead of knowing that they're equal, you need to know that two sides are Not congruent. Similar, but what does similar mean? Proportional. And if they're proportional, this angle has to be congruent. That's when you would use SAS. All right, so for example, could you prove that these two triangles are similar? Yes? How come? The angle is congruent, and you divide by 2 for both of those sides. So these two sides are proportional, and the included angle is congruent. What does included angle mean again? The one that's between the two sides. Okay, so explain why these triangles are similar, and if they are, write a similarity statement. So take a look at this first one right here. So we have two triangles in number 1. What else does it tell you in this picture? PT is parallel to SR. Okay, can we fill in anything else? Do we know anything else about these two triangles? Where are the vertical angles? PQT, so this one right here, and SQR. Okay.
And then we know that angle P is congruent to angle R.
Angle P is congruent to angle R. Why?
Give me an angle bisector, and now we make it interior.
Oh, they're alternate interior angles because this is a transversal. So PR is a transversal because it connects these two parallel lines. So then these two are alternate interior angles because they're in between the parallel lines, but on different sides of the transversal. So then can we prove that they're similar now? Using which of those 3 theorems? Angle. AA, which is not Alcoholics Anonymous, but angle. Okay, so angle. Because if you have 2 angles, what do you know about the third one? It has to be congruent. So really, this is like saying AAA, like a battery, all right? But you don't need that other A because once you know the 2 A's, you can leave it at the 1A. Or I'm sorry, you can leave it at that. You don't need the third A, okay? I always love a good sobriety joke. Nothing goes over well. Okay, what about this one? First of all, where are my triangles? PQR, so this one right here, and RQS? PRS. Okay, all right, PRS. Looking at this, which theorem do you think we're going to probably try to use? Side, because they give us all the side information. So if we're proving it by side, then what do I need to do to figure out if that works? Got to find the not congruent sides, but proportional sides. Okay, so if this is 9, 6, and 6, and this is 4, 4, and 6, what sides do you think are proportional? The 6 and 6 ones? Okay, so probably since these two are the same and these two are the same, that would be like 4 over 6 and 4 over 6, and then what would be the other one? 6 over 9, and we have to see if they're proportional. So can you reduce 4 over 6? 2 over 3, and this also 2 over 3, and then what about this one? So is this one proportional? Yes, by side. So for this one, what's the similarity statement then? When we say similarity statement, what would be the similar triangles there? So triangle PQR is similar to PRS. No, PRS, I think PRS is right because you're going 4, 4, 6. So we'd want to go 6, 6, 9. So PRS is right. Good. All right, what about this last one? Okay, so we're trying to prove this little bitty triangle on top and the big triangle that outlines it. Okay, so we've got the little triangle on top and then the big one. Because when I first looked at this, I was like, but that's a trapezoid, so how would I? But you see, you've got to look at the big one that outlines it and then the little one. So what do you think we're going to use here? Probably side something, right? Because we have some sides. So in our little triangle, what sides are proportional to the big ones? 2 would go with what? 6. Why 6 and not 4? Okay, this is the whole thing is 6. So 2 would be proportional to 6, And 3 would go with what? 9?
Wait, but why?
Because, see, the little triangle is 2, but the big one would be the whole thing. So it can't just be 4, because that would be the side of the trapezoid. So you've got to do 4 plus 2 to give you 6.
You always,
Yeah.
that's a different color.
Why don't I do this? Why don't I say, all right, here's JKL, and then here's the other one, and it's JMN. So the big one would be right there, but pretend that my marker actually lines up where it's supposed to. Do you see it now? Okay. All right, so that's why we said it has to be 6, because you've got to put together 2 and 4. Because the side of this is actually 6, and the side of this is actually 9. So this one's 2, this one's 3. 2 goes with 6, 3 goes with 9. 3 goes with 9. All right, do those reduce to the same thing? 1 over 3 equals 1 over 3. All right, so we have side and side, but what else do we need? We need an angle. Which angle specifically would we need? J? It's J in this one, and it's also J in this one. What property lets me say they're congruent? Reflexive. So if these are congruent, then what theorem did we just use? Side, angle, side.
So the only ones we have is AA, side angle side, AAA. No.
Just AA, SAS, and SSS.
Okay.
And the only difference is, instead of proving sides are congruent, we're trying to prove that they're proportional. But the angles still have to be congruent. Okay? So Bianca summed it up. AA, SAS, and SSS. That's it. And they work the same way, except instead of sides being congruent, sides have to be proportional. So you want to set up these fractional relationships. And again, if you don't like fractions, that's fine. Do them on a calculator, get a decimal. Just make sure the decimals are the same. Okay. Go ahead and do these 6 at your boards. So before you go up there, guys, you are completing the similarity statement if they work, and then also telling me which theorem you used. Go. All right, so for number 5, why could number 5 not be proven similar?
Because there's 2 angles on top and only 1 on bottom.
Okay, so you don't have enough information, and besides that, could you say anything else in this one? Yeah, you could say this one is congruent to this one, but that's still not enough because up here, these 2 are not the same as that one down there. So it's still not enough information. What about 6? Why was 6 a no? Yeah, if you did the sides, you found out that they weren't proportional. What proportion would it be, though? 16 over 88 equals 25 over... It's not 107. 132. Why is it 132? You've got to add them together. Good. You've got to add them together because the 2 triangles are the little one and the outside one. Okay, so. They love 2-column proofs. All right. I thought so too. Let's keep it going. Okay, so what do we know? A is a midpoint, and we also know D is a midpoint, so I'm just going to say A and D are MPs. If I know that, what does that tell me? If A is a midpoint and D is a midpoint, then I know a bunch of other stuff. What else do I know? If A is a midpoint, what do I know?
That it's half of the
Half of, so that means CA is congruent to AB. All right, so I can say CA is congruent to AB. And what else do I know? BD is congruent to DE. And that would be based on what? Oh, no. I know, I can't change it. My board just blew up.
Oh, the color.
The color thing. Give it a minute. We'll think on this. So I'm going to put 2, and then I'm going to say definition of midpoint. Okay. Is there anything else that I know?
Angle B is congruent to angle B.
Angle B is congruent to angle B based on what? Okay, reflexive property. So we're going to say angle B is congruent to angle B. So that's that top angle. And then we can say angle B is congruent to angle B based on the reflexive property. All right, so I've got this one. I'm trying to prove that BDA, the little one, is similar to the big one.
BA is half of BC.
BA is half of what? How do you know that?
Midpoint.
If A is a midpoint, then you know that BA equals 1/2 of BC. And you also know that BD is the same thing, 1/2 of BE. So BD is equal to 1/2 of BE. So then what do you know about those two sides? They have the same scale factor, so they are proportional. So then what theorem can you use? Because if you know this is proportional to this and this is proportional to this, then you already know. So we can use side, angle, side. So I know already that BDA is similar to BEC based on side, angle, side. That's it. You guys essentially are doing, you know that everything you did on these practice, this is all 2-column proofs, you're just doing it in your head, right? Yes, that is what you do.
Yeah.
Well, then do it in your head and then write it down afterwards.
It doesn't happen when you write on paper. You know when you have a song stuck in your head and it's there but you can't say it? Like you can't like speak it because like it doesn't come out?
Or you know
Well, that's
Yeah.
the same thing with that.
Or you know the song's name and you
Yeah.
know it.
Like,
Okay.
It's like that.
I see this. I understand all of this. But I'm just trying to tell you guys that as soon as you look at this and you're like, oh, I don't know how to do these, or Angel's like, I never do these. Like, you do them all the time. You just don't actually write it out. Everything you did here, you did it. Not to mention that you wrote the theorem names. So you literally did the statement and the justification. You just didn't put it in a little T-chart. So if it's the T-chart that's freaking you out, then don't write the T-chart. I don't care. All right, but when you guys say, like, I don't do them, yes, you do. You guys are way better at these than you think you are. You build it up to make them like something horrible in your head. Literally half, yes, you did, SAS or ASA. You wrote them on the board.
Not like when you step, like each
Oh,
step.
come on. Half of what we wrote was just the givens. I think you guys make them more difficult than they are. Okay, so for your exit ticket, I want you to do 1, 2, and 3. And I said 4 is optional. Try it out. But I would like you to try it out.